This video will teach you how to do compositions of functions. So most of the time you'll see this notation, f of g of x. I like to rewrite this notation as f of g of x with parentheses instead of the open circle. Let's look at an example. For this example, let f of x equal 5x plus 4 and g of x equal 3 minus x. Let's first find f of g of x. So the first thing I like to do is replace whatever is in the parentheses on the inside with the actual function. So g of x is equal to 3 minus x. So we'll make that substitution for g of x. To make this process easier, I want to do a simpler problem first, and then we'll get back to doing our problem f of 3 minus x. But I want you to see the similarity. So let's just say you're finding f of 2. Now you would just take this 2 and you would substitute it in for the x in f of x. So you would say that's 5 times 2 plus 4, which is 10 plus 4, which is 14. And that's your answer. What I want you to keep in mind is that when you're finding f of anything, something like 3 minus x, it is the exact same process as if you were doing it with just a number. So you are going to plug this in for the x in f of x, the whole thing. So instead of multiplying just 5 times 2, you're going to multiply 5 times whatever is in parentheses here. 3 minus x in this case, and then don't forget your plus 4 part of f of x. Then you can distribute and simplify. So we'll distribute our 5 and get 15 minus 5x plus 4, which will get us negative 5x plus 19 for our final answer. Let's do another example. Let's find g of f of x. So again, I like to substitute what's inside the parentheses with f of x, which in this case is 5x plus 4. And just like if we were finding g of 2, we would plug in 2 for the x in g of x. So that would be 3 minus 2 to get us a final answer of 1. So in the exact same way, we're just going to take everything that's in the parentheses and we are going to plug it in for that x in g of x because g is on the outside here. So we'll have 3 minus 5x plus 4. So the parentheses here are very important because you want to distribute your negative. So you'll do 3 minus 5x minus 4 for a final answer of negative 5x minus 1. So you can see that for two functions, f of x and g of x, that f of g of x and g of f of x will give you different answers. Our second example is let f of x equal 2x plus 7 and g of x equal negative 5x minus 1. Let's find f of g of x. So remember, if you see this notation here, you probably want to rewrite it like this. It's just a little bit easier to know what to do. So if you feel like you're ready, you can pause this video and try it yourself and then check your work. So we are going to replace g of x with its equation. And then we're going to take what's in the parentheses and we're going to plug it in for the x for the function that's on the outside here. So we're going to plug it in for this x here. We're going to substitute negative 5x minus 1 for that x. And then all that's left to do is simplify. So we have negative 10x minus 2 plus 7 for a final answer of negative 10x plus 5. Now let's find g of f of x. So we'll rewrite it. And again, go ahead and if you feel like you're ready, go ahead and pause the video and try it on your own and check your answer. So we'll plug in what f of x, the function for f of x, and then we're going to make that substitution into the function g. We're going to substitute this in for this x. So we'll have negative 5 times 2x plus 7 minus 1. Negative 10x minus 35 minus 1 is equal to negative 10x minus 36. And that's our final answer. Now let's do one more example with a quadratic. Let's let f of x equal x squared and g of x equal x plus 4. Let's first find f of g of x. So we will replace g of x with its equation, and then we will plug in what's in parentheses in for the x in f of x. So we'll have x plus 4 squared. Now, what's very important when you see that written like this is that you remember that that means this, so that you FOIL first, outer, inner, and last, so that you don't just get x squared plus 16, but you get x squared plus 4x plus 4x plus 16 for a final answer of x squared plus 8x plus 16. It's so important that you remember to FOIL anytime you see this right here, x plus 4 squared. You need to not just square the x and the 4, but make sure that you FOIL and get that 8x in the middle. Now, let's also do g of f of x. So if you feel like you're ready, go ahead and pause the video. We'll replace f of x with its equation, and then we'll plug in whatever's in parentheses into the x into g of x. So our final answer is x squared plus 4. Now let's look at some examples where we actually put in numbers for x. In this case, we're going to let f of x equal x squared minus 3 and g of x equal x minus 9. So let's find f of g of 5. So first of all, we can rewrite it so it's a little bit easier notation. And what we need to do is we need to find what's in parentheses first. So we are going to find g of 5. We know that we need to go to our function g of x and plug in 5 for the x. So we'll have 5 minus 9, which is negative 4. So we'll make that substitution of negative 4 into our original, because that's what g of 5 is equal to. So then we can make that substitution for g of 5 is negative 4. And then we know what to do with that negative 4. We're going to plug that in for x into f of x. So we'll plug this negative 4 in for that x. So we'll have negative 4 squared minus 3, which is 16 minus 3, which is 13. And that is our final answer. So if we have a number here instead of x, then we are going to get a number for our answer. If we have an x here, then we'll have x in our answer. Let's do another example with these two functions. Let's find g of f of 2. So we'll do with some parentheses first. So we'll find f of 2 first. So we'll plug in 2 for x into f of x and get 4 minus 3, which is 1. We'll make that substitution, and then we'll plug in 1 for x in g of x. So we have 1 minus 9, which is negative 8.